Our last example of converting a complex number into its polar form is given here as our z sub 5. We have minus 8 minus I. Take note that the coefficient of the real part here stands for our x, and our coefficient for our imaginary part stands for our y, because we can actually determine that by plotting it on our Cartesian plane to determine further what are the needed requirements. Because if we're going to talk about the polar form, it's actually in this manner. R is equal to, sorry, it's not R, it's our given complex number, z sub 5 in this case is R, times cosine theta plus I sine theta. The theta is actually the angle formed from the initial side, which is actually here, just like in a unit circle, until the point of existence for our complex number, and our R is called as the modulus of our complex number. So for our point here that would correspond to our complex number, negative 8, so we can have it here 1, 2, 3, 4, 5, 6, 7, negative 8, and negative 1 here. So our point is somewhere here, negative 8 and negative 1. Okay, that's the location of our point in the Cartesian plane for our given complex number. We're again giving this consideration. So the first thing we need to do is the length, identify the length, okay, of this, or the modulus of that. So we are going to use the formula you have here for your R is actually equal to the modulus of z sub 5, which corresponds to the, let's write it this manner first, for our complex number, which is the square root of the squares of the coefficients, or the sum of the squares of the coefficients, negative 8 squared, negative 1 squared, okay, because our x here again is negative 8 and our y is negative 1. So you will have here the square root of 64 plus 1, you will get here square root of 65. This is the value of R intended for this output here. That's square root of 65. What we need to do here now is to identify our theta. Our theta is actually on radian measurement in terms of pi. But how can we solve for our theta? Take note that if we talk about this angle here, just simply this triangle here, let me choose another color, just the triangle formed, okay, by the length and the location of the point, we have here a certain angle that is developed here, and that's our theta. Okay, this is the theta that we can actually use to determine the value of this one here. If I may, if you will allow me to expand the figure, so probably it would look like this. Okay, it would look like that, right? This is the angle needed, okay, for our theta, and this is actually negative 8, okay, or in the sense of triangle, it's actually positive 8 and 1, right? Because there's no negative measurement. This means this is 8, this is actually 1 here. So how can we determine the angle form? Now, looking into that, we can actually use here the ratio of a sine or even tangent. But since in the previous videos we use a sine, let's also use a sine. Since we already know this to be square root of 65. Now again, it's okay to use tangent, it's okay to use cosine, but just to be consistent with what we did before, let's simply use here sine of our theta being the opposite over the hypotenuse. Okay, so the opposite side is actually 1 over, you have here square root of 65. So you will have here the angle is the arc sine, okay, of your result of 1 over square root of 65. Now, to be consistent with what we did, and even if it's possible to use degrees here, let's try to make sure that our calculators, if you're using one, are set in radian measurement. Okay, because usually in doing formulas or representations, especially for polar form, you can even use degrees and radians. But since we've been using radians, and later on there's also another way of writing in complex number, and in that manner we are actually suggested or advised to really use radian measurement. If you're going to use your calculators in identifying the angle for this, and since we don't have a specific radian measurement for this, we only have here an approximation. Please set your calculators into radian measurements. You have 1, the arc sine of 1 over square root of 65. you will actually get here a result of 0.124. Probably I'm gonna use 2 decimal place only, approximation in radian measurement. If you're going to use degrees measurement, you could actually get, if I'm correct, 7.13 something. Okay, it's still good, but then again, to be consistent with what we did, we've been using radian measurement. Even in the very first example, we also use radian measurement. So why not use radian measurement here, which is again very important as we move to the next form as well of complex numbers. Now with this as our theta and our r already identified earlier as square root of 65, our z sub 5, which is identified as -8 minus 1, can be written, or its equivalent polar form is r, which is actually identified as square root of 65. You have your cosine, your theta in radian measurement, 0.12 plus I sine of 0.1 and 2. This is its form. Now, if we're going to make it even shorter using this form, which is this is a shorter way of writing that, you can have here this form. You will have square root of 65 CIS, and then your theta again in radian measurement, which is actually 0.12. Again, let's just be consistent with what we did, because in the previous videos, we've been using radian measurement. If I may, you will have here radian measurement. You have here also radian measurement. This is also in radian measurement. And even the very first example, where we also use some approximation, we use radian measurement. So let us be consistent with what we did. Okay, so by the way, we used here sine, but of course, if you are not convinced with your hypotenuse, you can even use tangent here. And I'm going to assure you that you will still get the same expression as long as you will use the same radian measurement instead of degrees. Okay, so our next video will be using this first 5 examples in the use of the polar form, because in that form we call it the Euler form of complex numbers. There is even a shorter way of representing them, and in that case, again, as mentioned, we'll be using radian measurement for that writing. Let's have that in the next video. So we'll be reviewing all of these 5 results, and we'll be writing them in their Euler forms. Thank you very much for watching.